Well, you gotta love rolling around in a police car. Everybody gets out of your way. It's too much fun. Got a problem though. They told me don't shut the car off. Why? Well, it's not gonna restart. That's not a good thing. So today on Tech Garage, we're gonna put this police car back in service. Well, they told me not to shut the car off because it wouldn't restart, but no worries. I'm here at Tech Garage and Brian's here, so I'm gonna give it a go. So let's cut it off, see if we got some restart. Oh, we don't have anything, nothing. No dash lights, no sirens, no anything. That's not good. Well, welcome to Tech Garage, presented by rockauto.com. Got a 2017 Taurus. That's right, I said a 2017. Brian, runs great, shut it off, nothing. I'm suspecting a battery.
You know, it could be how slowly you drive. It's really a good candidate, 4 years old. That's clearly been replaced before.
Yeah.
And the clue I heard was you got it here, meaning the alternator took over once you got it running. So that leads me to we got to do a voltage check here on the battery.
That's the first thing you always do. It's called OCV, open circuit voltage. Just going right across the battery to the positive and the negative. It'll just give you an idea of the battery. This one here is everything's conked out.
Over 12 volts. It's not bad. We're at 1.3, 1.4 volts, buddy.
Exactly. Yeah, that thing is definitely shorted internally. There's no saving that one.
No.
Why does that happen? Well, I got a pretty cool exercise for you. I know you're a mathematician. You're into all this mitigation stuff.
Got my
you
notepad.
got your whiteboard, man. Stay with me here. I'm going to go quick, all right?
All right.
So we got a regular car with an alternator. You're driving down the road, bam, your ignition's drawn about 6 amps,
Okay.
right? Turn the headlights on. If it's some old headlights, maybe 15 amps.
Okay.
I'm just giving you some estimates. Go down, I got the wipers on, it starts raining, and there's another 6.
Okay.
Well, because it's raining, I got the windows up, so I turned my high blower on. There's 20.
All right.
Rear defogger starting to fog up. You're right in the passenger seat, steaming everything up. So that's another 25. Got my infotainment system drawn about 4. Then I come to a stop. After that stop, guess what? I'm sitting there waiting. The coolant fan comes on. There's 30 amps right there. And then I hit the brakes. Because I'm stopped, there's another 6 amps, man.
You spend a lot of time on the brakes.
I do. Calculate that, mathematician.
Buddy, that is 112 amps right
Wow.
there.
Think about that. Not to mention the electronic steering, the suspension system, the brakes, all the autonomous driving. We could tack on another 30 amps to that, man. We're at $140, $150. Even with the high output alternator at idle, we're putting out about 90 amps. It's not cutting it.
No, and this is a police interceptor package, so that's as heavy of an alternator as it gets coming to us from Ford. So low idle, low RPM. Police cruisers do a lot of that. Tremendous amount of heat out here. I think we're a candidate for a new rockauto.com AGM. Let me start getting this guy out.
Yeah, well, before you do that, it's really important. I need to put that saver in there because this is huge, man. This right here, this is actually a battery saver that keeps the information in the car. Today more than ever. I know Tech Garage, you've all seen a battery replaced. You know, even next segment, we're going to talk about why it's so important to have that draw. We talked about in show 1 that DLC. We're going to plug this in. We're talking about feeding things like adaptive learn. This car actually learns your driving habits. So I know because it's shifting like an old man's driving.
Slow,
yeah, I got to get in it, bam, and kick it.
Yeah.
Well, what about the throttle learn? What about the accelerator pedal position sensor? All that stuff's adaptive learn. More than ever, it's critical. I'm going to hook this up, get a demo set up. Got some tips on that battery, don't you?
I do have some tips on this, and what he just said, that is the perhaps the most important tool nowadays when you're swapping out a battery. Use the memory saver. You will thank us later. So very simple. Before I just take this battery mounting strap off, 2 10mm nuts here, easy to work on. You want to do a visual inspection here. Again, little clue to me is this Optima AGM battery was not factory from Ford, so there's already been an issue. So I'm looking for anything in the battery mounting tray. It's tight. All those bolts are tight. There's no corrosion down there. The battery mounting strap seems to be good. It's not moving anywhere. So it could just be an amp replacement, replenishment issue. So I'm going to go ahead and get this guy out, get started. Very, very simple to do. You know how to do this. I'm going to head back to the rockauto.com shelf, grab an AGM battery, and we'll be back with more Tech Garage presented by rockauto.com in just a minute.
Tech Garage, presented by rockauto.com, is brought to you by Magic Creeper, the most versatile creeper ever. Borla, the world's most winning exhaust. And by rockauto.com, all the parts your car will ever need.
Well, boy, Brian made short work of that. The battery's out of our cruiser. There's a big hole there. Well, why is that? Well, it's over on the bench. We're ready to talk batteries and understand batteries. Welcome back to Tech Garage, presented by RockAuto.com. Now, what is a battery and what does it do? Well, we'll get into that in a minute, Brian, but it was interesting. You did that OCV, open circuit voltage, on the cop car over there.
Yep.
Had barely nothing. That was embarrassing. Well, we got one from Rock Auto right here, fully charged. Not the one for the cruiser, just another demo, but I want to show you the difference. If you look at that, 12.86. That's good. And what's really weird, though, check out this chart right here. And I'd had people write in and said, man, that's not true. Oh, it's absolutely true. Look at 12.86 volts is fully charged. 11.89 is 0% charged. You got no amps.
That's not going to do you any good at all. And you think about cold cranking amps, super important on a police cruiser. In fact, on every car. Regular cranking amps, reserve capacity, all those things matter. But voltage is nothing without the amps behind it.
Boy, you need that more than ever. In today's cars, we talk about that. And that's what Tech Garage is all about. We're about this autonomous driving. We're about all the sensors, right? Well, we get a lot of cars here at Tech Garage. They come in with an ABS, anti-lock braking system light on. We go scan that, and all it is a simple low voltage. The system's so smart, it shuts it down because it doesn't want you to think you have the safety and security of ABS when the battery can't handle the load.
Back in the old days, you know, when your headlights were starting to get yellow and dim, you could let it go, ride it out, make a calculated decision, I'll wait another month or two. Nowadays, what that means, if you're smart enough to be watching those headlights, go ahead and be proactive and get the right voltage in that system. All the other dependencies are waiting for the balance in the electrical system.
Sensors, oxygen sensors, millivolts, right? We're talking about the computer command control. Computers get really stupid when we start dropping some voltage. It could be phantom codes. It could be all kinds of things. Listen, it really starts here at the battery, man.
It really does.
And you know, there's different types or configurations of the battery. What you got over there?
Absolutely. Well, you've got modern day AGM batteries, which are awesome. More about that in just a second. But what really matters is your top post, side post configuration. There's no extra wire, there's no extra cabling under the hood these days, so you got to have the right post connection to get everything in there properly, get the battery clamped down. Now, the AGM, the absorbed glass mat technology, is incredibly powerful when you think about off-road, rough conditions, a lot of heat transfer. When you look at the old school lead plates and how this whole thing fails, look at this, buddy.
Yeah, well, think about it. There's an electrolyte, which is made up of sulfuric acid and water. And the old school, how a battery works, well, it's a chemical reaction. It goes from the gray lead to the sponge lead, and it blows through there and it makes a charge. Well, before the AGM technology, that stuff would wear out and start flaking.
Absolutely. You talk about vibration. Why does that matter? If it's loose in its mount, if you're driving off-road, doing hard condition driving, there it is. There's the degradation. Amps are not going to flow through that type of resistance.
No, and you said to secure that battery because that stuff piles up in the bottom, and once it starts touching this, just like our battery, it's shorted.
Yep.
Well, before you run with ours, though, hey, I need your help. I want
right.
to talk about a little bit of voltage drops right here in the cable, some things you can do right at the house. I got a voltmeter, I got it set up to volts. So he's going to the center of the battery terminal and the terminal itself. This is cool because it's voltage drop. Got a biggest draw right here on a car called a starter. So if I crank this up, watch the meter, and when it cranks over, you can see we're dropping a little bit of voltage. That's checking for resistance. So if you had crud or corrosion right there, man, I may drop 1 volt there. Think about the implications on all those computer systems we just talked about.
Oh, yeah. Again, voltage isn't transferring, and you got to have it. The electrical output of this guy is the ultimate enabler for all that other magic technology we talk about and love on a daily basis.
Well, you got some work to do, but I got a couple other tests I'll show you. You want to get that installed? Yep. So there's a couple other ones you can do. One is called a leakage test, and you can do this also in the driveway. You can put one on the positive or the negative terminal. It doesn't make any difference. And then you're going to take the other lead and you're going to go around. You're checking for any voltage that the actual electrolyte's causing. If it's leaking, it'll show a voltage. Now, we go back to that first chart. You see that the specific gravity or the weight of that electrolyte is directly related to voltage. So that's cool. So you can go get one of these hydrometers here and dip it in if you had a maintenance battery, suck it up in there and look and see the actual weight, the specific gravity of the electrolyte in there. Or if you're real fancy, you can use one of these refractometers right here. Put your little drop right there, bam, look in it. and you can see it right here on the graphic. We took a picture of it. It'll show you the specific gravity of the electrolyte, which directly relates to voltage. Once again, we don't want to lose any voltage. Now, you can get these tools. We got them all at rockauto.com. Go in there, clean your connections, make sure you got a good connection all the way down to your starter, your battery, all your grounds. Brian always talks about those PCM, ECM grounds. This stuff is critical today. It's not so much about the battery, it's about having that correct power, and that's what you want to have. So hopefully we helped you there. Well, Brian's wrapping up that battery. We're going to change gears and we're going to head into the LS lesson. Right after this break, we'll be back with more Tech Garage presented by rockauto.com. LS lesson, LS build. We're getting along with it. Welcome back to Tech Garage, presented by rockauto.com. Brian, we're moving right along, and in true Tech Garage fashion, you got your old shop vac out and cleaned it up. You don't like a mess.
No, I don't like a mess. I like to be methodical and super clean.
Yep, no doubt. Well, he's about ready to take his head off, but before he does that, let's bring you up to speed. You can see on this side, we left it intact. He took all the rocker arms off, and what he did after that, he come down and took the exhaust manifold off so he can go ahead and gain access to the bolts. Boy, that's exhausting. Now, once he took the rocker arms off, he didn't just throw them in a bucket. If you look at the wagon right there, this is the most critical part. Every one of these parts are mated to its other counterpart. So the rocker's going down to the push rods, and then it's going to match the valve. So each one of them's labeled. Brian has them on the tray, the organizational tray, where they go to each one of the push rods because they have a wear pattern. You can build this economically as long as you stick with those wear patterns and put everything back together. Now, down in the front here, we actually have the timing system. That's the next component here. I dropped the oil pan so I can gain the access to the oil pump right there, and I took the oil pump drive off. You saw that last show. Right here is the actual cam gear, and down here is the crank gear. So if I pull this off, it's nothing more than slipping off. I've already taken some of the bolts off here just so you can see. Take that off. We're probably going to replace that as well. We'll keep that organized and the bolts organized as well. And then there's a thrust plate right here. Brian, I'll start on this. I'll take this thrust plate off. I got the bolts loose already for the audience, but you got to start pulling that head.
Perfect. One large head bolt left. I've got it broken free. Just going to back it out. Well, I remember the old days, you probably do too, when these cast iron heads weighed a ton. Let's go into its singular spot right here, dead center. And I'm going to remove this head. Now, good practice, they're still heavy. Put your leg up here and support it. If you're fortunate enough to work on an engine stand like this, I'm going to roll it up, tilt it back, get a hand underneath it. Careful, those edges are sharp. And I'm coming right up off and over here gently on rags. No steel on steel, no aluminum on steel. All right, head gasket. This is worthy of inspection here. You're looking at these bridges in between, John, and this all looks really good. I don't see any breaks. I see cooling passages, right? Everything looks good, non-obstructed at all. And the head gasket looks good.
That'll tell the story, Brian. Any crosses there, any of those compression readings? Remember those compression readings earlier? Well, if we were getting adjacent cylinders, it could be passing between that head gasket. Warpage, we'll check for all that later. The head, we'll spend a whole episode on checking that, but we got to get the lifters out.
Let's see if we can get a lifter up out of here and get a good look at that as well.
What's really cool, those old 350s used to have the lifters here in the gallery. Well, this one's not. It's covered by the head there on the LS motors. So you have to pull the whole tray off, and then maybe you can grab one and slide it out.
There you go, a little surgery.
If you're lucky. Look at that.
There we go.
Wow, roller lifters.
Yeah, look at that.
Very cool. Right. Now, if you had some old lifters that are stuck, you can use some old racer's tricks, man. I have this little lifter installer here. You put it up on the top, got a slide hammer, pop it out of there. If you don't, well, simply get some carburetor cleaner, take some of that varnish off, work it, work it, work it. It'll come up out of there. Our LS lesson is progressing well. Speaking of lessons, we're going to Garage Ed next. Stick around. We'll be back with more Tech Garage presented by rockauto.com.
Tech Garage, presented by rockauto.com, is brought to you by Clamp Tight, the clamp making tool. Steel rubber products, quality crafted rubber parts and weather stripping. And by rockauto.com, all the parts your car will ever need.
Welcome back to Tech Garage, brought to you by rockauto.com. We've donned the fancy lab coats, and that can only mean one thing: Garage Ed. Today, we're talking about intake air temperature and engine coolant temperature sensors. Pretty cool stuff, John.
It really is cool stuff. It's about talking about the actual air coming into it. What's the temperature and the temperature of the coolant? Why do we want to do that? Well, it's all about that stoichiometric once again. Cold air, we need more fuel. Not as cold air, not as much. So here's how it works. This is an intake air temperature sensor right here on the board, and I have an engine coolant temperature sensor. Well, they both work the same way. Take a look at this graphic. They're actually negative coefficient thermistors, or they could be positive coefficient. We don't care. It's just measuring resistance. And what happens is when resistance changes, you can see the chart down there. At different temperatures, you have different resistance value. Now, the computer, he can't feel it. He doesn't know what's going on, but he does know voltage. So once that voltage correlates to that chart, it can tell what to do with the fuel delivery. Now I can actually show it to you right here. I have one, and if you're going to measure one at the house, you can do this right at home. That chart's available. You can go look at it on the internet and find it. Switch your meter over to ohms of resistance. Once I did that, you can look at the chart. I'm at room temperature and I'm at 3,200 ohms of resistance around there, 230. You look at the chart, we're perfect for this temperature. Now the cool part is, if I take this and I heat it up just like the engine would with the coolant, you can see it going down. Gets hot, resistance goes down. Well, resistance goes down, more voltage is sent back to the computer. He knows exactly what temperature it is, and he knows where to make the fuel delivery calculations. Now I got it hooked up to the scan tool, and I can show it to you in action. That's pretty cool because I can come over here through a little manipulation in the board, and we can look at it. Now I'm going to take the air temperature, I'm going to change it. Pretend you started your car. Well, when you started your car, you can see on the right, it went to about 102 under the engine compartment, and then what happens? Well, now that should about stay the same, but here goes the engine temperature. As my car's heating up and heating up and heating up, bam, I go all the way up with the engine temperature. That's what's happening. So in the morning, they should be about equal, and then once it starts running, the air temperature should stay the same and the coolant should start to rise. That's a good diagnostics. We're actually looking at it here of how the sensor works, but what if the wire harness is not working and the computer's not getting a signal? Hey, no worries. Brian's got us covered.
Well, cool is critical. Now I got this sensor. This is the engine coolant temperature sensor harness. We're going to check this, make sure it's reporting back to the computer properly. The sensor itself is, of course, stand on your head, do a dance, sing a song, and you can get down to it. It's way down in there. We don't know if we've got to change that yet or not. Remember, it lives in that cooling passage where antifreeze is flowing by, so it can actually measure it, exactly what John showed you. We are going to measure the wiring harness. So, now, here's a little tip. When you're pulling that connector off, sometimes very gingerly get a flat blade in behind there, release the hasp, and just take your time working that back off. That's tip one. Tip two is, you're doing this in the driveway, you need all the help you can get. I have a scan code reader that plugs into the OBD2 port. We'll show you what that's going to do. It's Bluetooth connectivity to my phone out here or a tablet, and that's really helpful because you can see the results as you go. So we're reading currently minus 40 degrees because it's disconnected. That tells us the ECU thinks this engine is at minus 40 degrees. And if we were to start it, if it would even start, we'd get a ton of black smoke. It would be dumping a bunch of fuel in there, telling the injectors, do your thing to heat me up. Well, when we take our fancy tool, I keep this in the top drawer of the toolbox. So what we're going to do is jumper this connector right across both posts, and we're going to take this status from minus 40 degrees to its full measuring potential, which is 302 degrees. You see the change? 40 to 302. What that means is when you jumper it is, this wiring harness is good. It's reporting full potential of voltage back to the ECU, which means if you were try to start it now, you wouldn't get any fuel because it would say, you're way too hot, no more fuel for you. So we validated that the wiring harness is good. If we still had a problem, it would be time to change that engine coolant temperature sensor. Again, stand on your head, get sideways, and then you can get it out. But not terribly hard to understand, but super critical. This guy is yet one more key enabler to the ECU power balance equation. Speaking of cool, Tom is over there with John.
Tom, we talked about the ECT, the engine coolant temperature, and the IAT, but you know, once again, it's part of a system. I mean, you got a water pump, you got a coolant, you got a thermostat, everything going on with that system. It makes sense to just get the whole part.
You know, what's becoming more common is having a complete assembly, so you don't have to guess. And if the parts are all failing at the same rate, you might as well replace it as a unit. It really started out with the strut spring assembly a few years ago. And now, yeah, it even extends to thermostats. The new cars often come with plastic thermostat housings that fail, sometimes even before the thermostat. So here we have a Fiat 500 example, it's the thermostat housing, it's the temperature sensor, it's the thermostat all in one unit.
Yeah, and you think about that with the strut. I mean, time's money, even for the professional technician. By the time I'm taking that spring and strut off and the whole 9 yards, I just spent 2 hours and a headache. I could do it myself right in the driveway with the whole assembly. Same thing there. You take those thermostats out. How many times are you breaking those bolts off? Or you know those old thermostat housings are going to crack every time you put them on there. This is huge.
Right, and with Rock Auto's reliably low prices, having an assembly and saving 40% on it becomes even more significant. You're saving 40% on a $100 assembly versus 40% on a $10 thermostat.
Exactly. You're doing the job right and you're doing it once. You don't have to keep doing it again. Saving a ton of money. Check them out on rockauto.com. Well, we're about out of time for today, so we're going to wrap it up with Brian, man. See what's going on.
Well, let me hit some electrical load. Let me start the car up and validate the repair. We got headlights. We got E3 lights. I'll tell you what, I feel really good about the repair. Upgrade to the AGM battery. Our cruiser's ready for business.
Boy, it is, Brian. You got me all set up. I can be in pursuit of the bandit. I'm ready to go, no doubt about it. Hey, what a great show today, man. Our LS build, we went through the actual head, and we even got the camshaft pulled. That strategic approach of looking at the stuff when we took it apart, and segment one, when we did all those tests, it come to fruition. It's all coming together.
Absolutely. It's everything. That prep and that attention to detail is everything on a rebuild like that, but I love that project.
Yep, Garage Ed, our sensors, man, piece by piece, we're climbing, we're looking at inputs. Pretty soon we'll switch to outputs, but unfortunately we're out of time for today. So keep up with us on social media, Twitter, Facebook, all that good stuff, YouTube. But don't worry, we'll be back next week with more Tech Garage presented by rockauto.com.
Production assistance for Tech Garage is provided by Chapala College, located in Marianna, Florida. Founded in 1947, Chapala was ranked recently as one of the top 3 community colleges in the United States.